All right, this one's actually easier than it looks here. All you have to do is just distribute the x through all of these terms. So x to the third plus 6x squared minus 7x. That's it. That's it. All right, this one, I want to make sure that each one of these terms on the left goes through each one of these terms on the right once. So I'm just going to start with the x. So x times x cubed is x to the fourth. X times 2x squared is going to get me 2x cubed. And x times 2 is 2x. All right, and then the negative 1 times the x cubed. All right, negative 1 times 2x squared. And then negative 1 times 2. All right, and then I want to put all my like terms together. So what's my highest power? X to the fourth. All right, so how many total of those do I have? All right. All right, I'm just going to cross them off as I go to make sure that I get them all. How many x cubes do I have? 1, because I have 2 minus 1. So I'm going to get 1x cubed. How many x squareds will I have? Okay. X's? 2. And constants.
Wait, where'd you get just 2x? Oh, yeah, I see it.
Got it? All right, again, we want to take everything in the left and make sure that it goes through the right once. So 3x squared times x squared is 3x to the fourth. 3x squared times 4x is 12x cubed. And 3x squared times 3 is 9x squared. All right, so I ran out of things for the 3x squared to go through, so I move on to the next one. Negative 2 times x squared is negative 2x squared. Negative 2 times 4x is negative 8x. And negative 2 times 3 is negative 6. So I put all my like terms together. My highest power is to the x to the fourth. I only have 3 of those. X cubes, I've got 12 of those. X squareds, we've got 9 minus 2, so I'm going to get 7 of those. And x's, I've got negative 8x, and then negative 6 constants. All right, this one I've got 3 terms on the left to go through all 3 terms on the right, so I'm going to have a much longer list. So x squared times 2x squared is 2x to the fourth. And then x squared times x, negative x, is going to get negative x cubed. And x squared times 1 is positive x squared. All right, so then I move on to the next one. So x times 2x squared is going to get me 2x cubed. X times negative x squared. And 4, nope, what am I doing? I haven't moved on yet. X times 1, just x. And the last one I move on to the 4, so 4 times 2x squared is 8x squared. 4 times negative x is negative 4x. And 4 times 1 is 4. All right, so I put all my like terms together. My highest power is x to the fourth, so I've only got the 2 of those. X cubes, I've got negative 1 and a positive 2.
So 1x cubed.
All right, x squareds, I've got a positive x squared, a negative x squared, so I need to cancel those.
Oh.
Okay. This x squared and the negative x squared, they canceled. But I still have an 8x squared over here, so I still do have some x squareds. X's, we've got a positive 1 and a negative 4. So that gets me to negative 3x and then 4 constants. Now the nice thing about these is you're back to just FOILing quite a bit, and it doesn't really matter what order you go in because multiplication is commutative. It means the order doesn't matter. You're going to get the same answer no matter what. So if you want to multiply the first 2 terms together first, that's fine. If you want to do the second and the third together, that's fine. Even if you want to go first and third, you can do that. It's not going to hurt either way. So what did you guys do? Did you just go left to right?
Yeah.
All right, so I have x times x, which is x squared. X times negative 2, that's negative 2x. 9x and negative 18. All right, now I have that, and it's still times an x minus 7. So inside the parentheses here now I've got x squared plus 7x minus 18 when I simplify, times an x minus 7. Now I want to distribute everything over here on the left through the stuff on the right.
If you move the opposite way, distribute it to right and left.
Yeah, if you like going less numbers in between, you can move that around because again, it's commutative, so it doesn't matter what order you do them in. All right. So, but if I go left to right, x squared times x, which is x cubed, x squared times negative 7, that's negative 7x squared. 7x times x is 7x squared. 7x times 7 is negative 49x. And then negative 18 times x is negative 18x. And negative 18 times 7 is going to get me a positive 126. All right, so we combine our like terms, so I only have the 1x cubed. X squareds, I have negative 7 and a positive 7. They cancel. X's, I've got negative 49 and negative 18. So that's going to be 67, negative 67x. Sound right? Yeah. All right, plus the 126.
See, I just got 126 x cubed. I don't know what the heck I did there.
This one's much the same, so we can just go left, right. X times x is x squared. X times 7 is 7x. 5 times x is 5x. 5 times 7 is 35. So when I combine my like terms, I get x squared plus 12x plus 35. And then I still have to multiply that by this negative x plus 1 out here. Alright, so x squared times negative x is negative x cubed. X squared times 1 is x squared. 12x times negative x is negative 12x squared. 12x times 1 is 12x. And then 35 times negative x is negative 35x. 35 times 1 is 35. Combine my like terms. X cubes, I only have the negative 1 of those. X squareds, I've got a positive 1 and a negative 12, so negative 11x squared. X's, I've got negative 35 and 12, so it's going to give me a negative 23 of those, and then 35 constants. Same thing, left to right. So x times x is x squared. X times negative 2 is negative 2x. Negative 9 times x is negative 9x. And negative 9 times negative 2 is positive 18. Combine my like terms, I get x squared minus 11x plus 18. And I still have to multiply that by this 3x plus 2 I got hanging around out there. So x squared times 3x is 3x cubed. X squared times 2 is positive 2x squared. Negative 11x times 3x is negative 33x squared. Negative 11x times 2, negative 22x. And then the last one out here, 18 times 3x is going to give me a positive 54x. And 18 times 2 is a positive 36. All right, so when we combine our like terms, I just have these 3x cubes by themselves. X squareds, I've got positive 2 and a negative 33.
Negative 31.
X's?
22 and 54, which would be
A negative 22 and a positive 54. So positive
32.
32.
And then just 36.
There you go. All right, I think I have one more of these. How about 51? All right, so 2x times 3x is 6x squared. 2x times 1 is 2x. 1 times 3x is 3x. And 1 times 1, 1. Put my like terms together in here. And I get this. And I still have this x plus 4 out here to deal with. Now when I distribute these three through those two, 6x cubed, 24x squared. 5x squared plus 20x And then I get an x and a 4. Put my like terms together, I have 6x cubed. Then x squareds, I've got 24 and then 5 of those, so I've got 29 x squareds. X's, I've got 21. Constants, I've got 4. Pretty good. I think that was it. Any other ones? Okay. Multiplying, adding, and subtracting, better. Also, I think everything you guys had for me was multiplying, which means adding and subtracting should be good.
Yeah.
Okay.
This is what I hate.
Whoa!
I remember this part.
I haven't even introduced it yet. You're already hating it.
I hate this though. I think.
All right, now, factoring and solving polynomials. There are 3 different kinds of these that are like special. So you need to recognize them as being a little bit special. The first one is the sum and the difference of 2 cubes. So the first thing we should look at is, you guys are pretty good at recognizing perfect squares now, because you've seen them a lot, but we haven't really dealt with perfect cubes very much. So we should talk about what that is, first of all. What's a perfect square?
Number times itself.
A number times itself, and you get a nice whole number, right? So like, what are some examples of those? 16, 4, 25. Okay. So perfect cubes are going to be what?
We know that.
Right. That to give you a nice whole number. All right. So what would be an example of a perfect cube? 16 would be what times what times what? That is not 16. 8. Okay. So 8 is 1.
I got you.
Yes.
64.
Okay. What number is that times
4.
itself?
I got another one.
Okay.
1.
Right. Because it's 1 times itself.
I got another one.
Okay.
0.
Yeah, I guess. But 0 we're going to leave out.
I got you.
Yes.
27.
Okay. What is that times itself?
3.
Okay.
I got you.
Okay.
125.
All right.
That's fine.
Okay. One more. Actually, 2 more.
I got you.
216.
1,000.
That's the other one that I wanted. 1,000 is 10 times itself 3 times, and 216 is 6 times itself. These are going to be the ones that you guys see the most often. Most of the time, they're not going to go above 6. But if they do, like a lot of times, they just use the 10. Right. Now, that's not to say that you won't have perfect cubes that are bigger than these. It's just that you're not going to see them very often. These are going to be the ones that you see the most often. Just like in the perfect squares, you see lots of 4s and 9s and 25s, right? Because they're small, so they're easier to work with.